So now that we know how to correctly graph either quantitative or qualitative variables, we're going to take just a second to look at how sometimes we can misrepresent our data in graphs, and that misrepresentation can either be intentional, where we are trying to deceive, or it can just be unintentional, where we're maybe misleading, but it was an unintentional misled. So what I have here on the screen are two different graphs, or two variations of the same graph, I should say. And over here on the left-hand side, you'll see that we have the graph, and this graph is related to life expectancy in years. The right-hand graph over here is still the life expectancy in years. We are talking about life expectancy going from 1950 all the way to 2010. Now again, these are both the exact same graphs of the same data, I should say. But you'll notice that these two graphs appear to be implying quite different things. The graph over here on the right, or on the left, is implying that there is a massive increase in life expectancy from 1950 to 2010. So if we were to look at this graph that has this almost, it's really sharp increase right here, this rise in life expectancy, we might think, wow, that's really pretty cool. We're doing really, really good for life expectancy, and it's just going to keep on going at this wonderful rate. But in reality, this graph here on the left is only looking at the age range between 68 and 78. So we're only, in essence, graphing the expectancy, the life expectancy for those people as it grew from 68 to, as you grew from 68 years to 78 years. Also notice that even this kind of zoomed in version of the left-hand side over here also doesn't start at 0. So if that's the case, let's turn our attention over here to this graph. And with this graph, you'll notice we are still graphing life expectancy from 1950 to 2010. But the scale on the left-hand side over here is now starting at 0, and it includes all of the values between 0 all the way up to 80. So the scale on the left-hand side is from 0 to 80. And because of that, notice what happened to the graph. We are still graphing that life expectancy, like I said, but now, although we do have an increase in life expectancy, it's not nearly as dramatic as what the previous graph was trying to show. Yes, there is an increase, but it is not quite the increase like we're seeing over here on the left-hand side. So, some of the things you want to consider when you're looking at a graph like this has to do with the scale on the side of the graph. Are you consistently graphing in equal increments? So although they are graphing in equal increments over here, the scale didn't start at 0. So those are some of the things you want to look for in a graph like that. Now let's look at this graph here. In this graph, we're looking at the burglaries for 2009 in the US. And we have a bar graph. We're comparing two things to each other. We can see here that for July through August, this graph is implying that there is an 18% burglary rate. And then for all of the other months, it's an 8.2% burglary rate. Well, the problem with this graph here is they took the months and they grouped them in not equal amounts, let's say. Here we have July and August grouped together as a single bar, and then they grouped the remaining 10 months together in a single bar. What this makes it look like is that you are twice as likely to have a burglary in July and August than you are in any of the other months. Well, now let's look at what this bar graph should be represented as. So here I have the same data, and this time, instead of grouping the months together, we have every single month represented along the horizontal axis here, and their individual frequency or their relative frequency shown. Notice that July and August are the highest months, but it doesn't, when you're looking at this graph here, you can see that just because I had burglary rates that were higher in July and August, they're not twice as high in July and August than they were at other months, which is clearly what this graph up here is implying. So although you have July and August showing to be the higher of the 12 months, notice also that September's kind of high, October, November, even December is high, right? So it's misleading, I guess is the point, to group July and August together and separate the others out in that way. So when you're looking at graphs, you want to make sure that however they're grouping, it makes sense. So let's take a look at another graph. This graph right here is a graph that I snipped or I copied from the Texas Department of Health's COVID dashboard. And this was back in 2020, September of 2020. And I know that this is, although the numbers would be a little bit different, I know that this graph would have been a similar graph to what they had all the way up until last semester. Now let's look for just a second here. This is, again, this is going to be quantitative data, so this is a histogram. And what we're grouping here is, or this is, let's just look at the graph, I should say. What we have here are categories. And this is the age groups of groupings of fatalities. So if I were coming over here, and I don't know if you can really see this graph really well, so let me tell you how they categorize the data here. This first bar over here represents those who are under 1 year of age. Then the second bar would be 1 to 9. The third bar would be those people that are 10 to 19 years old. Then we have 20 to 29-year-olds, 30 to 39, 40 to 49, 50 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, and 80 and above. So what did they do wrong here in this graph? So similar to the graph that we just saw, which was an example out of a textbook, this is actually coming from the real world. And what they did is they took the category of age 60 to 69 and split it in half. So here they have one bar representing 60 to 64. They have another bar representing 65 to 69. They did the exact same thing for those ages between 70 and 79. Both these bars here should be in a single category. So they have the categories here which were consistently divided up by years of 10 up until you reach age 60. And then for whatever reason, they divided these two, ages 60 and ages 70, into two separate bars divided by, grouped in years of 5. So this was actually from the website up until really recently. They have since, it looks like, updated their numbers. And I'm glad to show you that this is now how they have edited, I suppose, this graph. You'll notice that if we came back to those problem years over here, 60 to 69, 70 to 79, they have now grouped them as they should in a single bar so that it's consistent with the other groupings that they had here in their graphs. So kind of interesting right there. The last graph I want to discuss with you has to do with pictures and 3D objects and those things. Now, here on the left graph, I've got a 3D graph, and I think 3D graphs are really pretty cool. They catch my eye pretty easily. They're easy to graph. Excel can make a 3D graph pretty easily, as I'm sure other spreadsheets and stuff can do. But we want to talk about what impact this 3D graph can have. If you notice, I can look at the percentages of this graph over here, and I know that the crude cost, which is at 48%, is higher than the taxes if we're talking about gas prices here. So crude costs are 48%, taxes represent only 32%. 48 is obviously larger than 32, but notice when the graph is 3D like this pie shape here of 32% seems to hold a little more weight to my eye. My eye is giving the overall impression that this 32% is really a thicker piece of the pie, if you will. The overall area of that piece appears larger to my eye because we've given it a little bit of depth here, a little bit of perspective. And that's not really the case. So this graph, while it's really pretty cool, is not the best way to represent the data. If you look over here to this plain old pie graph that you have, it's pretty clear to see now that that crude cost of 48% is a much larger piece of the pie as opposed to the taxes down here, which are 32. So although this graph is 3D, it's kind of cool, I like it, maybe we need to just settle for the two-dimensional graph to be able to convey the material or to convey my data in a more easily and understood way, as well as getting a better picture of those actual pieces of the pie. So these are just some of the examples of some graphical misrepresentations that can take place, whether that is intentional or unintentional. And you want to keep these things in mind, not only as you create graphs, but also as you encounter graphs in the real world.